For this problem, we're given two numbers represented by two lists, and we must find the sum of the two numbers. So an example is the input of list 1, 5, 4, and list 2, 5, 4, 3. So 5, 4 would be 45, 5, 4, 3 would be 345, and the output would be 093, which is 390. To solve this, I'm going to create a new list, and then we will add from the pointer 5 plus 5 plus the remainder. So 0 plus 5 plus 5, so total is equal to 10. Then we're going to say total modulus 10. So 10 modulus 10 is going to be 0. We'll add 0 to this list. And then R will equal 10 divided by 10, which is 1. So then we'll move pointer here. Here we'll add 4 plus 4 plus 1, and then equals 9. 9 modulus 10 is 9. 9 divided by 10 is 0, so remainder becomes 0. Now our pointer can't move on here. So if either one is null, we'll just add any remainder plus that. Okay, so we are returning a linked list of integers. We are getting a, that should be 1, linked list L1 and linked list L2. We're creating a linked list called final. We have a pointer to point to the head that starts at the head of list 1, a pointer that starts at the head of list 2, and a remainder integer. And so while P1 is not equal to null or P2 is not equal to null, so in the case of 5, 4, 3, we want it to keep going even when we've run out of values here. So if both are not null, so in this case, then we're going to create a total of 5 plus 5 plus the remainder. We're going to add the total modulus 10, which would be 0 in this case, to our new list, and the remainder will be the total divided by 10, which would be 1. And then we'll move our pointers up. In this case, then we go again. Our remainder, we'd add our remainder plus that, we'd add 8. So 0, 9. Now our P1 would be equal to null, so we'd skip this. Our total would be P2 plus the remainder, which the remainder in this case is 0. But if it weren't, we would add the remainder, or, well, we'd still add the remainder. But so 3 plus 0 is 3, and we will add this, and net, once it is, let's pretend this was a 9, then we'd have 14, this, and this was a 9, then this would be 0, and we'd have a remainder of 1. So once we've run out of here, then our loop will stop because there's no more next for either. Then it's going to check if the remainder is not equal to 0, so in this case it would be equal to 1. Then we're going to add that, whatever the remainder is, to the end, and then return the final.